Howdy! This is your friendly neighborhood physics teacher here, and we're going to go over some practice problems to help you get ready for the remastery of your 2D motion exam. So these are not going to be exact questions you'll see. They're just extremely familiar, aka same setup, different numbers, different scenarios, but pretty much the exact same questions you will be asked. We're going to go step by step. We'll do the guess method, and we'll break down each of these problems. So, problem number 1. Chris was taking a break from studying his physics exam and walks to the duck pond. Alex decides to go to the bridge and toss rocks into the pond. The bridge is 0.34 meters above the water, and the rock lands 2.4 meters away from the bridge. So those are our givens. When in doubt, draw it out. So we have our bridge. Bridge. We have a Chris standing on said bridge. And we got the pond. Okay. The bridge apparently didn't go far enough. Oh well. You get the idea. So then he throws a rock, and it goes somewhere along there. So it says the bridge is 0.34 above the water. Basically what that's telling you, above. Now the key thing is above. Which direction do you look when you hear above? Hopefully you look up. So that's going to end up being your delta y. That's in your y direction. So if we're writing down our givens, our delta y is going to be 0.34 meters. And the rock lands 2.4 meters away from the bridge. So away, if I said, oh, it's way over there, think about I'm motioning away from me. So away from me, kind of like in the distance, would be that. So that is our delta x. So the key thing there is away. So our delta x is going to be 2.4 meters. Now there's always hidden givens. So it's something we always know. We always know what the acceleration due to gravity is. And this is where Miss Verona and I kind of differ. I make acceleration due to gravity always negative because it's going down. In that case, though, I would have to come up here and make my delta y negative. The reason I would have to make my delta y negative is because the rock is going down. Now, Miss Verona keeps her acceleration positive, so she can keep her delta y positive. It doesn't matter as long as they're the same sign, you're fine. And then another given that's like an always given in this case is that your VIY is 0. Now remember, that is your initial velocity in the y. And the reason your VIY is 0 is because he's throwing it horizontally. So at the beginning, it's only moving in the x direction. It's not moving in the y in the beginning. Another thing to think about is when you draw the parabola, like if you just like take all the mess away, you're just drawing the path of the rock. The path of the rock is something like that, which, if you look at a full parabola, which we need down here, so I'll go ahead and draw. This part is equivalent to this part. And so if your Vy is 0 at the top here, this is, come on, right? Really? Don't you love it when the pen doesn't work? There we go. This is equivalent to your top because it's only half of a parabola. In this case, that's where you're starting, so this just becomes your initial. So that's another way of looking at it. So that's why your VIY is 0. Okay, here we go. So first thing we're looking for is the ball in the air for 0 seconds. So hopefully you realize if it's asking for seconds, you're looking for time. So you're looking for time. So let's write out our potential equations. So we have, come on, there we go. We have delta x equals Vx times time. We have our delta y equals Viyt plus 1/2 AGT squared. We have our Vy final, or final Vy. The final y equals our Viy plus AGT. And we have V final y squared equals Viy squared plus 2AG delta y. Now remember, we will give you these equations. You do not have to memorize them. You just need to remember what each letter is. So we are looking for time. So the first thing we need to do is decide what equations have time in it. So this one does, this one does, this one does, that one does not. So we can't use that one. So we're naming it down to 3. So now let's look to see what we have. So in this first equation, do we have our delta x? Yep. Nope, come on. We have delta x. Do we have Vx? We do not have Vx, so can't use that equation. Do we have delta y? Yes. Do we have our initial velocity in the y? Yes. We're looking for time. Do we have our AG? Yes. And we're looking for time. So that's a potential. Let's check. Gotta check everything. Do we have our final velocity in the y? Nope. So we can't use that one. So we're left with our delta y equals Viyt plus 1/2 AGT squared. Now, if you kind of sit there and do that out, I know it's time consuming because you're like writing out the equations and then making check marks. It will help you a lot. Doing that kind of method will help you a lot. So we're going to be using our delta y equals Viyt plus 1/2 AGT squared. Now we just plug in. Our delta y is a negative because it's going down, 0.34 equals 0 times time plus 1/2 negative 9.8 t squared. After this, it turns into algebra. You're just simplifying now. 0, come on, 0 times anything goes to 0, so that can go away. So we have a negative 0.34 equaling, now we can go ahead and multiply those together. So that's a, so 1/2 times 9.8. That gives you a negative 4.9 t squared. Now we need t squared by itself. So what do we have to do to the negative 4.9 to get the t squared by itself? Hopefully you said divide, because it's being multiplied. The opposite of multiply is divide. And what you do to one side, you gotta do the other. So the t squared stays the same, but then you can put in your calculator negative 0.34 divided by negative 4.9. See how the negatives cancel now? And you're left with 0.069. But we're not quite done. We're looking for just normal t. We have a t squared. How do you get rid of the squared? The opposite of squared is square root. And what you do to one side, you got to do the other. So you get that your t equals, after you plug in your number into square root, it takes 0.26 seconds for the stone to hit the ground. So there we go. Now we know our time. So let's go to the next question. The horizontal velocity. So horizontal velocity. So we're looking for the horizontal velocity of the rock when it's tossed. So horizontal velocity. So we are looking for our Vx. Because remember, x, think about the graph. X is in the horizontal, y is in the vertical. So we're looking for our Vx. So let's come over here and look at our equations. We're gonna make that disappear. Come on. Maybe make it disappear. So we can start over and look at all our equations. There we go. So now we're looking for Vx. So the first thing we need to do is figure out what equations have Vx in it. That equation has Vx. This equation does not. That equation does not. That equation does not. Well, that makes life easy, right? We only have one equation that has Vx in it. So we're kind of stuck with our delta x equals Vx times time. So now we just plug in. So we know delta x is in our givens. So we know it's 2.4. We're looking for Vx, and we just solve for our time. Now we need our Vx by itself. So this is being multiplied. So the opposite of multiply is divide. And what you do to one side, you gotta do to the other. So that cancels out. So you just plug in 2.4 divided by 0.26. And you get your Vx to be 9.23 meters per second. There you go. Hot diggity dog. That was pretty simple. So now it's saying we're looking for our vertical velocity right before it hits the ground. We're looking for our vertical velocity right before it hits the ground. So vertical is y. So we're looking for our Vy, but right before it hits the ground. So that's going to become our Vfy. That's our final velocity. So again, so we're going to go over here to erase our work so we can get a fresh start. So we're looking for our Vfy. So let's mark out all the equations that don't have Vfy. That equation doesn't. That equation doesn't. This one does. That one does. So let's see if we have everything we need. So we have VFY, we have our initial, we have gravity, and we have time. So we can use that equation. Let's check the other one. We have our initial, we have gravity, and we have delta y. So we can use either one of these equations. Either one will get you the right answer. Hint, this one has squares, so you have to square root and deal with all that stuff. I would pick this one personally, just because it's a little bit easier. So that's why I would pick that one. So let's pick that one. So we have our VFY equals VIY plus AGT. We're looking for our VFY. Our VIY is 0 plus negative 9.8 times the t we saw for part 1.26. So this is pretty easy math. All you have to do is multiply those two together, and you get that your final velocity, if you plug in negative 9.8 times 0.26, you get a negative 2.5, rounding 5 meters per second. There you go. So that's your final velocity in the y. Does it make sense that you came out with a negative number? Hopefully you said yes, because as the rock is going down, remember negatives in physics just tell you the direction. So your final velocity would be negative because right before it hits the ground, it's going down. So now it's asking for our horizontal velocity of the rock right before it hits the ground. What's so special about your horizontal velocity? Hopefully you said it's constant. Your horizontal velocity is constant. The reason it is constant is because there's no force in the x direction. There's no force in the x direction. So there's nothing that's making it go in the x direction. As soon as it leaves your hand, there's nothing else touching it, so there's no force. The reason it's able to go down is because there is a force of gravity. So that's why there's acceleration in the y direction, but there's no acceleration in the x direction. So your velocity in x just stays constant. So it just stays 9.23 meters per second. The reason that question is there to make sure you understand this constant, that your Vx is constant. No matter where you are, your Vx is going to stay the same. So this problem right here is called projectiles in the horizontal, hence why it starts out horizontal. That's why it's called projectiles in the horizontal. This is equivalent to your Leo the Lion problem. This is very equivalent to your Leo the Lion problem. Okay, so that's problem 1. Let's jump to problem 2. So Captain Jack Sparrow was upset because the rum was gone. So he launched a cannonball at 34 degrees angle at the ship that was 34 meters away. And it took 5.06 seconds to hit the ship. So the first thing we got to do is write out our givens. So let's write out our givens. So the first thing it gave us is our angle. Bless me. The first thing it is gave out our angle. So our angle is 34 degrees. The next thing it gave us how far away the ship is. Again, that away is telling us, look way over there, So it's giving us our delta x. So our delta x is 34 meters. Next thing it says it took 5.06 seconds. So it gave us our time, 5.06 seconds. And don't forget, we have some quote-unquote hidden givens, right? So we always know that our acceleration due to gravity is negative 9.8 meters per second squared. We also know, because we already wrote it down, that our Vy at the top is 0. And another thing we know, that our Viy equals our Vfy. Our Viy, so I'm saying that your initial velocity here, your Viy, equals your Vfy. Just your Vfy is going to end up being negative, because it's going up this direction, but then going down that direction. So whatever the speed it started at, it's going to be the same speed that it ends at. Just it's going to be in negative direction. So those are a couple of givens. So there's a few more in the mix. Well, not a few more. There's just one more in the mix of our hidden givens there. Now, looking at our givens. So this one we're going to do a little bit. I know like last one we just jumped right into the equation. But this one we're going to look at to see what we can solve for first. So looking at our givens, what can we solve for? We have a delta x and we have a time. If we scroll up to our equations, so if we scroll up to our equation, we have delta x, we have time, so we can solve for our Vx. So let's go ahead and do that. So our delta x equals Vx times t, 34, equals what we're looking for, times 5.06. Now the reason I'm doing this is because all we have information is kind of in the x direction right now. For projectiles, we need x and y. So we need to get some information in the y direction. So we're going to do 34 divided by 5.06. And that'll give us a 6.72, if you round, meters per second. So we figured out our delta x. If we're given an angle, you know you're going to end up drawing a triangle. You know you're going to end up having to draw a triangle. So let's just go ahead and draw a triangle. We're going to draw a triangle down here. So we have our triangle. So this is theta. Now, if we're thinking just physics, that is going to be just your plano velocity, initial velocity. This is going to be your velocity in the x, and this is going to be your initial velocity in the y. Another way of looking at it is this is your hypotenuse. If this is your angle, this is your opposite, and this is your adjacent. Another way to even looking at it, this is your c, and then this can be This one doesn't matter, but we can make this A again. We can make this B for your Pythagorean theorem. So each one of these sides have like 3 labels. Make that an O. Whoops. I switch colors. There we go. Look like a C to me. There we go. So, and then what we have right now is our delta x. So our delta x equals 6.72 meters per second. We also have our theta, which is 34. Yep, 34. I was just checking. Oops, don't go away. So if we have our delta x and our theta, we can solve for our other 2 sides. As long as you're given the theta and you're given one of the sides, you can solve for the other 2 sides. And there's some equations that we need to write down. That would be our SOHCAHTOA. So sine theta is your opposite over hypotenuse. Cosine theta is adjacent over hypotenuse. And tangent is opposite over adjacent. So I would say let's solve for this one first, because once we solve for this one, then we can do Pythagorean theorem to solve for this. So we have adjacent and we have opposite. So which one of these has adjacent and opposite? Ding, 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 ding. We will be using our tan. So over here, tan theta equals opposite over adjacent. So we just plug in what we got now. So our theta is 34. Our opposite is what we're looking for. That is our initial velocity in the y. And our adjacent is 6.72. We want our VIY by itself. It's being divided. The opposite of divide is multiply. And what you do to one side, you got to do to the other. So you get your VIY. And you can just plug that into your calculator. 6.72 times theta of 34. Now, double check and make sure that you're in degrees. You can do that on your phone. Now, I have an Apple phone, so I can sit through and tell you how to do an Apple phone. I am not very sure how to do an Android. I do apologize. But if you have your calculator on your Apple phone, tilt it to the side so you get everything. And you want to make sure I know this doesn't make any sense, but you want to make sure in the bottom left corner it says rad, R-A-D. Because if you click on it, it'll end up saying rad at the top and then degrees at the bottom. No, you want it to say rad in the corner and not rad at top. So that's how you do an Apple phone when you're sitting there doing your calculations. And then when you type it in, you kind of have to type it in a little bit backwards. So when you type it in your Apple phone, you have to type in your degrees first, then your tangent sign, and then multiply it by that. So you kind of have to work backwards when you're messing with your Apple phone. And again, I'm so sorry. I don't have an Android, so I can't tell you how to use an Android. I'm sure if you Google it, it will tell you how to use it. But again, I am so sorry. And you can get a 4.53 meters per second as your initial velocity in the y. And now you can just do Pythagorean theorem. So a squared plus b squared equals c squared. So your a squared would be 6.72 squared, plus we just figured out our b, which is 4.53 squared, equals, we're looking for our c, which is the hypotenuse, your initial velocity. So you just take your 6.72 squared, and you get 45.16 if you round, plus 5.353 squared. You get a 20.9 5.2 equals that. You just add those two things together. There we go. And you get a 65.68 if you round. Now, don't finish here. A lot of people finish here. We want just our V naught. We don't want V naught squared. So to get rid of that squared, we have to square root. And what we do to one side, we got to do to the other. So we're going to square root our answer, and you get an 8.10 meters per second. So there we go. So we sit there, before we even looked at the questions, we sat there and broke down all our velocities. So we got our velocity in the x, we got our initial velocity in the y, and we got just our plain old initial velocity. The reason we did that is because if you notice, every single equation has some type of velocity question. Now, don't forget, what's so special about your initial velocity in the y? If we go over here to our givens, it's the same as our final, it's just negative. So we can go ahead and write out that our final velocity in the y is the same, it's just a negative version of our initial. Ta-da! Now I know it's like this is a lot of work up front, but doing all this work, now honestly, you just have to read the problem and plug in the work we've already done. There'll only be a little bit of work now. So let's go back to the questions. So the first question states, the cannon is launched with a velocity of, now, if it just says velocity, it doesn't say velocity, horizontal velocity, it doesn't say vertical velocity. If it just says velocity, it's looking just for our plain old V naught. It is looking for our hypotenuse. So we already figured out our hypotenuse. So we scroll over here, and our hypotenuse is 8.1. So we did the work. So I can sit here and draw an arrow. That work goes here, and that is an 8.10 meters per second. So anytime it's just asking for just plain old velocity, doesn't say horizontal, doesn't say vertical, it's looking for our hypotenuse. And then it says the maximum height of the cannonball. So asking for maximum height. Maximum height. So that we are looking for our delta y. So we are looking for our delta y. Now, this does involve a little bit of math here. So it does involve a little bit of math here. So let's look at our equations. So we need delta y into the equation. Does this have delta y? Nope, so we can't use that one. Does this one have delta y? Yep. Does that one? Nope. Does this one? Yep. So now let's break it down and see what we got. So we have delta y, or that's what we're looking for. We have our initial, but we don't have time. So we can't use that one. So we're kind of stuck with this one. So do we have our final velocity? Yep. Do we have our initial velocity? Yep. Do we have gravity? Yep. And we're looking for delta y? Perfect. So we're going to use our VFY squared equals VIY squared plus 2AG delta y. So now we just plug in. So our final velocity we solve for to be down here. Negative 4.53. So we're going to do parentheses negative 4.53 squared equals 4.53 squared, just the same, just not negative, plus 2 negative 9.8 delta y. And now you just kind of simplify. So the first thing we're going to simplify is we're going to do negative 0.53 squared, and you should get a positive number. When you type it into your calculator, make sure you put parentheses around your number. So you would get a 20, or a jump, whatever that was, a 20.52 equals, and you should get the same here, 20.52 plus, and you go ahead and simplify that, you actually end up getting a negative 19.6 delta y. Now you can't subtract these two together because of this delta y. So we need to get this 20 over there. So it's being added right now. So the opposite of adding is subtracting. So you're going to subtract 20.52 to both sides, or 52, sorry. That goes away. And so if you type in 20.52, oh, we're going to get a 0, aren't we? So what did we do wrong? What did we do wrong? Because if you do 20.52 minus 20.52, you get a 0. And then if you sit there and try to divide, you're going to end up getting a 0. Key thing here is, where does in your parabola, your full-on parabola, where does your max height happen? Right here. So your max height happens right there. So we're not doing the whole parabola. This was us using the whole entire parabola, going from initial to final. But our delta y doesn't do that. Our delta y only uses half. So what you need to do is realize that your final velocity is going to end up being 0. Now, I know you're like, well, Miss Heath, why did you do that? Why did you show us the wrong way? Because so many people do that. They see final velocity, they plug it in, and then when they get 0 as the answer, they start flipping out. And I don't want you to do that. I want you to trigger and go, wait, I'm getting 0. Oh, hold on. Getting 0. Ha, ha, ha. 0 needs to be, our final velocity needs to be 0. So we're plugging in a 0 right there. So now 0 squared is 0. You still get 20.52 there. You still get a negative 19.6 there. But now when you bring that 20 over, the negative 20.52, you get a negative 20.52 equals a negative 19.6 delta y. And then when you need this delta y by itself, it's being multiplied. The opposite of multiply is divide. And what you do to one side, you got to do to the other. So you get that your delta y equals, you just divide that, you get a 1.05 meters. So that is your delta y. Again, remember delta y happens halfway. So you need to use that, your velocity at the top, 0. That's why we wrote it down. We do have to use it. The only time we really use it is for our delta y, but we got to use it. So the next question asks for our horizontal velocity. Our horizontal velocity. I think we already figured out our horizontal velocity So that's our Vx. So our Vx is just 6.72. So Vx equals 6.72 meters per second. Woohoo! The next part, it asks for our initial vertical velocity. I think we already figured out our initial vertical velocity. That's just our VIY. So our VIY equals, I rolled it over there, but in 4.53. 4.53. You see how doing all that up work, we've already sat here and done all this? Now it's asking for the vertical velocity of the cannon at the top. Now again, at the top, that's when your 0 comes into play. So at the top, your Vy top is 0 because it stops moving at the very top. And then it asks for your final vertical velocity, which will be just the same as your initial, just negative. So doing all that work up front. The reason I suggested that is because, one, you see your first question asks for your hypotenuse, and you have to do all that work anyway just to get your hypotenuse. So if you go ahead and do the work to get your hypotenuse, and then everything else was pretty much, you've already figured it out. The only work we had to do was for our delta y. And you have to do all that work anyway to get to your hypotenuse, so might as well just go ahead and jump into it. So hopefully that kind of helps. So for that problem. Last problem. So Miss Stanforth was jumping on a trampoline. The trampoline is 1.5 meters above the ground. She reaches the top at 1.3 seconds and performs a backflip. Miss Stanforth reaches a maximum height of blank. Don't forget to add your 1.5 meters to your answer. So when in doubt, draw it out. So she's on a trampoline. And it says that the trampoline is 1.5 meters above the ground. With Miss Stanforth jumping, she jumps up. But we want to know the maximum height. So the first thing we need to do, we need to figure out how high she jumps. Once we figure out that, then we can add our 1.5 to get our answer. But we have to figure out our delta y first. So let's write out our givens. So we know that at 1.5 above the ground is a given, but we don't need that until afterwards. It says she reaches the top at 1.3 seconds. So we know time is 1.3 seconds and performs a backflip. So that's the only really given that it gives us. But we know there's some hidden givens, right? We know that we have a g, which is negative 9.8 meters per second squared. So we have a g. We also know what would be her velocity at the top. So basically what would be her, because we're just trying to find the top, so what would be her final velocity? Hopefully you said 0. Because her jumping up, she stops, does a backflip, and then comes back down. So her final velocity is going to be 0. So there's only 2 hidden givens in this one. And we are looking for our delta y. So we need to find an equation that has delta y in it. So let's scroll up to our equations up here. We're going to do our little checklist again. If I can make these things disappear. And again, I know the checklist can be time consuming, but at least helps. So that doesn't have a delta y. There's a delta y there. That doesn't have a delta y. There is a delta y there. So we're looking for delta y. We don't have our initial velocity. So we can't really use that one. And we don't have our initial velocity, so we can't really use that one. Uh-oh. So we're not able to use any equation. So what do you think we need to solve for before we solve for our delta y? Yep, you guessed it. We need to solve for our initial velocity. So now let's see about our initial velocity. That has an initial velocity. This one does, but we don't have our delta y, so we can't use that one. This one has initial velocity. We have our final velocity. We have gravity, and we have time. And again, we've already established we can't use that one because it has our delta y in it. So we have to figure out, so before we do, where'd everything go? So before we do our delta y, we need to solve for our initial velocity because it's in both of the equations. So we're going to use our final velocity equals initial velocity plus a t. Final velocity is 0. We are looking for initial velocity plus our ag is negative 9.8, and our time is 1.3. We need to bring, well, let's simplify first. So it's 0 equals v iy. We plug in negative 9.8 times 1.3. You get a negative 12.74. We need our initial velocity by itself. So we're going to bring over this 12.74. And so we get our initial velocity to be 12.74. So you see why the negative is important? Because we need it to be positive meters per second. So now that we have our initial velocity, let's try looking at our list again. So again, doing this list, you saw that you just had to have your initial velocity because both equations that had delta y in it has our initial velocity. So again, so that doesn't have delta y, that doesn't have delta y. And again, you'll find out you can honestly use any equation. I personally would use this one because delta y is already solved for. So let's do that one. So we have our initial velocity times time plus 1/2 agt squared. So delta y, our initial velocity we solved for is 12.74. Our time was 1.3. Our gravity is negative 9.8. And our time is 1.3 squared. So then you just simplify. So you do 12.74 times 1.3, and you get a 16.56. And then you simplify this. So first you got to do is 1.3 squared. Then you can multiply your negative 9.8. And then you can multiply your 1/2. And so you get a negative 8.28. And then you just subtract those two numbers. And you get that off the trampoline, she jumps 8.28 meters. But remember, you have to add our 1 point, because it wants the maximum height off the ground, not off the trampoline. So we have to go ahead and add our 1.5 meters onto that. So we get that her max height to be 9.78 meters. There you go. So hopefully that helps. If you have any other questions, feel free to ask Miss Heath or Miss Verona. They love answering questions. Hope you have a wonderful day. Bye!